Bismillah, Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah, salatu wassalamu ala rasulillah wa ala alihi wa sahbihi wa ala amma ba'du. So today, in this uh, 27 of 27 of August in 2025, I want to have a little bit of explanations about failover and load balance in EIGRP and also in TCNP. So a while ago I've recorded a few videos, and this is the 8th videos. I'm going to explain you about load balancing and failover, but in this video we're not going to have the practice, because overall we want to explain the theory more deeply, more into the theory. So here, the first thing first that you gotta understand, there is two conditions of network when you have a network inside of your company or your house, whether you're using what ESPs. So imagine when you have a company and you only have one ESPs connected, and what will happen if the ESP connections is down? Exactly, your company will have a little bit trouble on the internet. In these situations, we have two ESPs, Internet Service Providers, which is connected to our core router inside of our company, inside of our office. There is two functions of failover or load balancing. These functions will lead you into redundancy, or exactly when one link is down, then it's going to have another link to achieve the destinations. So our destination was the internet, and our links is the ESPs. If you're using failover, this is the brief explanations. This is going to be a simple explanations. The failover means you're using one link and the other link will be a backup link. And when the first link is down or the main link is down, then it's going to use the backup link. But in load balancing, it will use both lines, both links, for to achieve the destinations. So what's the benefits and what's the concept is all about? The goal, failover. In failover, the main goal is to actually have the link redundant. So once the link is down, it have the backup, but the active conditions was the backup and the main link. The benefit is whenever the first link is down, it will immediately change into the second link. But the weakness is you can only use one link at the same time, and you cannot use both of them. And the other link that is backup will not do anything and will become deactive or not in use, and it's going to be a waste of bandwidth that we could use. So that's why load balancing have a goal to use both of them. But in the active conditions is like this: they're using two lines here. But just in case you question it, what will happen if the other link is down? It will have the same concept as failover. It will use the other link to become the way to the internet. So no matter what you choose, it's all the same to give you redundant. But load balancing has a lot more benefits because it uses both links to have more Mbps and more bandwidth. So an example, this ESP have 100 Mbps and this ESP have 100 Mbps as well. If you're using failover, then your company will only receive 100 Mbps to share to your clients. But if you're using load balancing, you're using both bandwidth. So what will actually happen when a data comes to the R3? In failover, it will only lead to the R2 and will lead to the internet. But in load balancing, it's going to be more complex. The data will transmit into a little bit more bits, and it will share both of them. They will use both lines to use for the data. Or rather, there's in situations when there is an active link, it will go to the R2. There's an active link that will go R1. In summarize, load balancing will use both of the lines, both of the links, and it will not make one of them AFK at the same time, just like failover. But what is the weakness? Exactly, the weakness of load balancing is it sometimes make debugs or make the packet confused. And not all protocols support load balancing, and it has need to be uh, high-end devices to use load balancing, because at the same time it is very it is a um, it is a hard job for the L3 to actually split the data to L2 and L1. It's another job. In usual situations, in failover situation, the job of L3 was only to forward the packets, but forward or filter the packets. But in load balancing, it has to transmit the packet into a smaller piece and will share it to both of the lines. So the benefit of load balancing, it will increase the throughput and it will increase the data sending. Because why? Because when it split the data will came there, it will not be a big chunk when one line, but it will spread, it will be split into two chunks, and it will be smaller and will be faster. Okay, so when do we use failover and when do we use load balancing? So load balancing is something that we call at HSRP or VHRP, first hop redundant protocol, or the link where you want to have then when your router is basically maybe not that good enough to have load balancing, or you just don't need to have load balancing on you because you don't want the router to have a bigger port to you. And how about load balancing? Load balancing could be used when you want to have more bandwidth, because you have two SPs. Though why don't you use two of them? Why don't you use both of them at the same time? But what happens if it is not ESPs? This is routers from your office. Okay, when the router's office connected to another router and the router of the data center connected to the ESPs. Now, it doesn't matter if you want to use both of them as load balancing, you could just use failover. But if you use ESPs, you need to, an example, you need to pay monthly. And when you use failover, you don't use R1, then the bandwidth will be a waste of bandwidth. It will be a waste of bandwidth. So that's why using failover will be good ways when you don't want to have when you don't want to give another way to your routers. But if you want to use both of them at the same time, then it's okay. If you're using it depends on what do you want to use. The study case is ASP provides links, the main link and the backup link, and the backup is active when the link is down, the main link is down. Okay. So this is the terms that affect the cause of EIGRP failure. So I've explained to you that is successor and feasible successor, or the main link and the backup link in EIGRP. There is another packet called feasible distance, or the distance that is reported from your routers from the neighbor, and reported distance is the from other neighbors to you. And one of the ways that you can manipulate the what's the name, when you want to use failover and you want to manipulate the way. So an example, in N1 we want to reach L3. We of course will use the 1313 IP address. But what if we want to use the 1212, because in the 1313 the bandwidth was very low, but the cost of this will have less than the cost of this. Then we're going to have the show. We're gonna see this show IP EIGRP. The delay in here was slightly lower, because when you use this we will only have one line. But what happens if the bandwidth is low? Then we want to use this. So how do we use that? The manipulation step. You gotta just insert the interface and have delay on whatever you wanted, and it will make the delay like this. Then it will use the 1212 link to reach the link. You could also change it by bandwidth. by using the bandwidth and just increase or decrease the bandwidth into whatever you wanted. And there is two types of load balancing: equal load balancing and unequal load balancing. So equal load balance, the previous method was about failover, but now we're going to explain about load balancing. In load balancing, you have equal and unequal load balancing. When you're using an equal load balancing to reach 444 from R1, it will use both of them. And what will happen here is the traffic share count is 1. Equal load balancing means that both of them have the same value and will use both of them at the same time. But unequal load balancing means that one of them has lower bandwidth and one of them has the bigger bandwidth. And this will lead into failover. But how do we manipulate it? The first time there is something called variance to count the visible distance. You can understand visible distance is the distance reported from your neighbor. And there's the trick here. You gotta count the visible distance from router 1, from the link 1 and link 2, and it will be divided and it will become the variance. And you gotta make it up. You gotta make sure to make it not decimal, and it will make the number to 17. So far it's 17, and we use the both of them. But as you can see here, the traffic share count is 120 and 7 because the other link is using lower bandwidth and the other link has larger bandwidth. So it will prioritize the larger bandwidth, but at the same time it will still use the bandwidth which is lower. So this means that it will send 120 packets from the first link, and when it's 120 it will send 7 packets from the second link. Maybe that's all from me. Thank you so much for watching. Assalamualaikum warahmatullahi wabarakatuh.